Hey guys, welcome back to the channel. So today we would be solving this daily Leetcode challenge. So the problem is number of zero filled subarrays, and let's go through this problem statement. So we are given an integer array nums and we have to return the number of subarrays which are filled with 0. Okay, a subarray is a contiguous non-empty sequence of elements within an array. So let's consider this first example. Here we are given this integer array and we can see that there are 6 subarrays. So let's try to count this 6 subarrays. So this 4 individual zeros would be subarrays of length 1. So we would be having initially answer 4, and then we are having these 2 subarrays of size 2, which is 0 0, and then here we have 0 0. So 4 plus 2, this is 6, which we have. So the total subarrays which are filled with 0 are 6. So let's see how we can solve this problem. So now this is the integer array which is given to us. So the naive solution would be, whenever we are asked for some subarrays, we can always generate all the subarrays and calculate the answer based on that. Let's say I'll just start iterating this array, and if I'll get an element which is 0, then I'll try to calculate the subarray starting from that 0. So let's start from this first position. So here this is not 0, so let's move ahead. Here this is also not 0, so let's move ahead. Okay, here this element is 0, so let's say I keep one answer variable. So currently it is 0. Now I see that one element is 0. Okay, then I can increment my answer. Let's say here we do plus 1. Then I'll just try to see the subarray of size 2. Okay, this is also 0. The second element is also 0. Let's say I increase it by 1 again. Okay, now let's move ahead. Let's say I am moving with this j pointer. Now we can see that this is not a 0 element. Okay, we can break it from here, and then we will again iterate on our I. So let's move this I ahead, and now the I would be here. So we can see that this is also 0. So again we will do plus 1. Okay, now we would be having our j pointer somewhere over here, because we will traverse a subarray from starting from this position. So this j will come here, and we will see that this is not a 0 element. Okay, we will just return from here. Again we will move our I ahead. Okay, so at this position we can see that this is 2 and not 0. So okay, we can skip this. Let's go ahead. Again this is 0. Okay, we can increase our answer by 1. Let's say my j is here now. So I'll start iterating this j. So my j would be here. Again this is 0. So again I can do plus 1. Okay, now let's move our j ahead. So here you can see that this is not a 0 element. Okay, let's travel back, move the I ahead. Okay, so this is 0. Do plus 1 to our answer. Yes, then again j would be here, because our I is here and we have not iterated over this subarray starting from here. So let's iterate this. Okay, so j would be here then, but this is not a 0 element. Okay, let's skip this, and then we can increase our I. Now our I is ahead, and here we can see that as this is not a 0 element, we will just iterate our I again. So I would be here, and we have breached our array length. So yes, we have traversed all this array. So now we have this answer, and this is 1 2 3 4 5 6. Okay, so the answer is 6. And here also we can see that for the first example we have the answer 6. Okay, let's consider the second example. It is 0 0 0 and 2 0 0. Okay, let's write it here. So again I have this nums as 2 0 0, then sorry, it was 0 0 0 and 2 0 0. Okay, let's start with the same idea. Our I would be here, then j would be here. Okay, and answer would be initially 0. Now as this is 0, let's do plus 1 to our answer. Again, as this is 0, we will move our j ahead. Okay, this is also 0. We will do plus 1. Again, j would be here. As this is also 0, again do plus 1. Okay, so then j would be here, but this is not a 0. Okay, then again we will move our I ahead. Here we have j now. Now as this was 0, we will do +1. Okay, and then let's move ahead with our j because this was 0 and again this is 0. Okay, do +1 and then j would be here, and since this is 2, we will travel back again and then move our I ahead. Now I'll just write this j now here. Again as this is 0, again do +1. Okay, then as this was 0, we will move our j ahead. Now at j, this is not a 0 element. Okay, let's move our I ahead then. Now again as this was not 0, then again I will move ahead. Here as this is a 0 element, let's add +1. Okay, now the j would be here. Now let's start iterating. As this is 0, so j would be here, and as it is 0, we will do +1. Okay, again now as j have breached the array length, again we will move our I ahead. Now I would be here, and as this is 0, we will again do +1. Okay, and now j was here, but we cannot iterate further because this is the end of the array. Okay, so let's try to calculate our answer. It is 1 2 3 4 5 6 and 7 8 9. So the answer is 9. Let's see if it is the correct answer. So yeah, indeed it is 9. Great. We can solve this problem with this approach, but the time complexity would be simply n square. Why? Because for each I, we are iterating our j, and in worst possible case, we will iterate our array 2 times for each element. Why? Because for each of the element, we are iterating the array again, and in worst case, if we iterate for all the elements, then it would be n square operations. So yeah, this is not an efficient thing. Okay, so let's see what we can optimize here. Let's take one example. Let's take this first example only. It is 1300 and 2004. So let's say this nums is 1300 2004. Great. Now we are interested in the subarrays which is filled with 0, which means we are interested in this part and this part, right? So yeah, this elements will not contribute to any answer. This will not contribute to any of the answer. Now as we want only the subarrays which will include only zeros, so we will just include this part, because the further subarrays which we will produce from this subarray will always have zeros. So this will contribute to the answer, and again same for this, we will use this to count the number of subarrays which can be produced using this part of the array, and hence we will get our answer. Now whenever we are given an array of length n, it will always have n into n plus 1 by 2 subarrays. Now you can go to the proof of this, but basically this is used to calculate the number of subarrays which can be produced from an array. So let's apply this formula here, as here the subarray is of length 2. So the total subarrays which can be produced in this part is 2 into 2 plus 1 by 2, which is indeed 2 into 3 by 2, which is 3. Okay, so 3 for here and 3 for here, so total it would be 6. Similarly, for this second example, the first part contains 3 zeros, 3 contiguous zeros, so it would be basically 3 into 3 plus 1, which is 4 by 2, which would be 6. And then for this 2, we have 2 into 3 by 2, which is equal to 3. So the total would be 6 plus 3, which is 9, which is indeed our answer. So yeah, now we know how we can get our answer, but let's try to see how we can efficiently calculate our this subarrays which are filled with 0. So the example is 1300 2001. Great. Now again we will use our same pointers, that is the ith pointer and jth pointer. Let's start our ith pointer from this starting position, and also we would be having our j pointer which will be used later. Okay, so what we will do is we will check if at the position of I is there any 0 element. Okay, So this is not a 0 element. Let's move our I ahead. Again, this is not a 0 element. Let's move our I ahead. Okay, so now we have 0 here. So we will start our j pointer from here, and also we will maintain a current variable. Let's say it is initially 0. Now as this is 0 element, like the element where j stands, it is 0. So we will increment this by +1. Okay, then we will move our j ahead. Now j is here, and again this is a 0 element, so we will increment our current by 1. Okay, now j will come here, and again as this is not a 0 element, our current would be 2, and since we got our subarray of size 2 which is filled with zeros, we can make our calculation based on n into n plus 1 by 2. So it would be simply 2 into 3 by 2, which is equal to 3. So we will add this in our answer. So our answer was initially 0. Let's add it by +3. Okay, so now our j was here. So we got to know that this was not a 0 element, so we can safely move our I ahead, and we will skip this. Okay, now our I is ahead, but this is not a 0 element. Let's move our I. So I is here now. Again, this is a 0 element. Okay, so again we would be having our current which is initialized to 0. Now as this is 0 and we have our j here, we will increase this by +1. Again as it was 0, j will be here. So this is also 0. Again add +1. Great. Let's move j ahead. So this is not a 0 element. Okay, so we can safely move our I ahead. But wait, let's not forget to calculate the answer based on this subarray which is filled with 0. So we got the subarray which is filled with 0. Okay, so we will calculate our answer, which is n into n plus 1 by 2, and it would be 2 into 3 by 2, which is simply 3. So again we will add 3 here, and now since the array is completely traversed, we can safely return our answer, which is indeed 6. Okay, so this is actually our answer. So yeah, and the time complexity here would be simply O of n, because what we do is we iterate each element only once. So we will iterate first this, then this, and then this, and when we iterate over this, we will start iterating our j pointer, and the j pointer will go somewhere ahead, and then instead of iterating this array which is traversed by this j pointer, we increment our I pointer where the j pointer is. So these elements are skipped from traversing 2 times. So this is indeed the proof of the solution, and it would be order of n. So yeah, let's code this solution. So let's maintain the array size. Initially I have the array size as nums.length. Again, then I'll calculate our answer in this answer variable. So let's maintain this. Okay, so let's add our I pointer now. So I, which is less than L, and we will not increment I here because we want to increment it based on the value of j. So here we will maintain some current, and this current would be simply 0, and again we will have some check here. If this nums of I is not equal to 0, what we can do is we can simply increment our I. Okay, so we can increment our I here, and we can continue. But what if this is 0? Then we will initialize our current. Okay, then we will initialize our j pointer, and j will start from I, and we will increment our j till it is within the bounds, and the number at this position is equal to 0. We will increment current also, and then let's move ahead j, and this will give us the number of zeros which are present in a contiguous subarray. Okay, so at the end we will increment our answer by current into current plus 1 by 2. Okay, so we will increment this, and at the end what we will do is we will increment our I. We will place our I where j was present. Great. And then at the end we can just return our answer. Okay, so this looks good to me. Let's try to run this. Okay, we will just submit this. So yeah, it gets accepted. So thanks for watching and subscribe to the channel for more such videos.